Hey guys, hope your revision's going well. So today I thought we'd actually go through some aiming for grade 5 papers. So this is specifically for those of you doing foundation that want as high a grade as humanly possible. This contains all of the hardest possible questions. And today we're going to be doing the paper 1, but then there's paper 2 and 3 that will come along later. So for those of you that kind of watched the grade 9 paper but then realise you're doing foundation, this would be perfectly for you. If you're doing higher, this won't be too useful, to be honest, so don't worry about that. But yeah, so let's just get straight into it. This is a 2023 practice paper aiming for grade 5. It's made by Edexcel, but keep in mind there is a ton, there's an infinite overlap between all of the exam boards, okay? So this is relevant to you even if you're doing AQA or Educast or something like that. So let's get into it. So first of all, we get started with right 124 is a product of its prime factors. So if you remember how to do that, you're going to do a factor tree. So we're going to write the number 124 and then see what we can divide 124 by. My personal method is that if it's even, I always half it, no matter what. So I'm going to write the 2 here anyways, and then what's half of 124? It would be 62. Again, if you're not sure, I would recommend using the bus stop method. So 2 does not go into 1, so put it there. 2 goes into 12 6 times, 2 goes into 4 2 times. And then again it's even, so I'm going to half it one more time. 31, and 31 is actually a prime number. There's nothing I can divide 31 by, so that's my answer. Now, to actually get the full marks, you have to write this. 2 times 2 times 31. And I always like to put 124 equals. So you can only get the method mark if you just do this tree. You have to actually write this last part here to get the full 2 marks. So you get 1 mark for the tree, 1 mark for the actual product. Okay, so for question 2, we need to find the value of y and also give a reason. So in this case, it's angles around a point add up to 360. So since we already have 70, we're going to do 360 minus 70, which is 290 degrees. And the reason is angles around a point. Whoops. Point. Ignore the E that gets placed. For some reason my pencil has a button that just writes an E. A point add up to 360 degrees. Nice and easy. So we've got 4 marks so far, nice and speedy. Okay, so a storage tank exerts a force of 10,000 newtons on the ground. And the base of the tank is in contact with the ground is a 4 meter by 2 meter rectangle. So we can even draw this out. And that looks like a parallelogram, but hopefully you get my point. It's going to be 4 meters wide and 2 meters tall. Work out the pressure on the ground due to the tank. So, pressure is equal to force over area. So we're going to take this 10,000 and divide it by some kind of area. Now, the area is always the area of the base, which in this case is a rectangle, which is 4 meters by 2 meters. So my area is just going to equal 4 times 2, which is 8 square meters. So then pressure is just equal to force, which is 10,000 over 8. Now how would you do this? Well, there's a few ways that you can do this. Is you can keep halving it. So if I divide the top and bottom by 2, I can just simplify the fraction, right? So this is how I would do it, is I would keep halving it. That gives me 5,000 over 4. Divide by 2 again. That's 2,500 over 2. And then lastly, 2,500 divided by 2. Again, you can use the bus stop method if you'd like. However, I know that this is going to be 1,250 newtons per square meter, which is already in the answer here, so that's fine. Okay, so again, just to do the bus stop method. And by the way, do let me know if you want me to go through the bus stop method each time it comes up. But 2 into 2 is 1. 2 into 5, it goes in twice, right? 2, 4. 6 is too big, so we go back. Remainder 1, to put the 1 there. 2 into 10 gives me 5. 2 into 0 gives me 0. So 1,250. Savio leaves his home at 7:30 to drive to work. He drives a distance of 50 miles, and he thinks he drives at an average speed of 40 miles per hour. If he's correct, what time will he arrive at work? So what they're trying to look for here is if you can kind of piece together what you need to do. Okay, so he needs to drive a distance of 50 miles, and he goes at 40 miles an hour. So what time does he arrive? So the first thing we should do is work out how long it takes him to get to work, then add it on to the time that he leaves. So 50 miles, so if you remember, speed is equal to distance over time. And if you'd like, you can use this really weird looking triangle, speed, distance and time. Because we want to work out time, we're going to cover up time and we're going to do distance divided by speed. So time is equal to distance over speed, which the distance is 50 miles and he goes 40 miles an hour. So 50 over 40, cancel out the zeros, that's 5 over 4, which is 1.2 hours. So if you'd like, I can go through that again. So 4 into 5. 4 fits into 5 one time, but there's a remainder of 1. So we need to put a decimal point. 4 into 10 gives me 2. And the remainder of that is equal to, so 4, 2 equals 2. And that'd be 5. So it's 1.25 hours. In other words, it's 1¼ hours. Okay. So if he leaves his house at 7:30, we're going to add an hour and a quarter. So that makes, if I add the hour first, that makes 8:30. And a quarter of an hour is equal to 15 minutes, right? And if you weren't too sure about that, think about it. In an hour there's 60 minutes, so a quarter of 60, you divide it by 4, which gives you 15. So then we're going to add another 15 minutes on. He arrives at work at 8:45. That's 3 marks. Pretty good, I think. In fact, his average speed was greater than 40 miles an hour. Well, how will that affect our answer? Well, let's think about it logically, right? If I leave to go to work and I travel faster, then it should take me less time, right? Like, let's say if you walk to school, it takes you half an hour, right? Now, if you get dropped off at school, a car goes a lot faster than you walking, so you get to school a lot sooner, which means he will arrive earlier. He will arrive earlier. So before 8:45. Here we have to solve an inequality. So all we need to do here is remember that whatever we do to one side, we do to the other. And when we solve, we want to have x by itself. If I look here, there are 2 things stopping the x from being by itself. There's a minus 27 and there's also this 7. Now, I always get rid of the thing that isn't attached to the x first because it makes my life a lot easier. So I want to get rid of minus 27. How do I do that? Well, I do the opposite of subtracting 27, which is adding 27 to both sides. And remember, whatever I do to one side, I do to both, right? So 7x minus 27 plus 27, it means I get rid of the minus 27, so that's 7x. And 8 plus 27 is going to be 35. Now, how do I get rid of the 7 in front of the x? Well, the 7 is timesing the x, so I'm going to divide by 7 both sides, which gives me x is less than 5. Cool. There are 240 cans of drink on a shelf. Each can contains cola, lemon, or orange. And it gives you this ratio. And it gives you a half of the cans of lemonade and a 12th of the cans of orange are removed. So work out the total number of cans of cola as a percentage of the total number of cans of drink remaining on the shelf. Okay, this is pretty hefty. So what we're going to do is we need to take it in steps. It's a 5-mark question, which means there should be 5 steps, which means it's pretty damn big. So here's what we're going to do. What would help me answer this question? Well, it says here half the cans of lemonade and a 12th of the cans of orange are removed. So wouldn't it be useful to work out how much that actually is? So if I say half the cans are gone, how many's half? How can I work that out? Well, I can work out how many cans of lemonade there were to begin with. So what we're going to do is we're going to turn this ratio into an actual number of cans. Okay? So we're going to do this. We're going to say cola. How many cans of cola are there? Well, we're going to turn this ratio into a fraction, and to do that, we take the number associated with cola, which is the 5, and we divide that by all of the parts of the ratio added together. So 5 plus 3 is 8, plus 2 is 10. And we're going to times that by the 240 cans. Okay? So 240, and to do this kind of fraction of an amount thing, we do 240 divide by the denominator, so divide by 10, which is 24, and times the numerator. So doing 5 times 24, which you should find is 120, but again, do the good old-fashioned column method. When you do the column method, I have quite bad handwriting, so I like to spread the numbers out, but it helps me make sure I don't times the wrong thing or add the wrong thing, which is where a lot of students go wrong, higher or foundation. 5 times 4 is 20, 5 times 2 is 10, plus 2 is 12. So 120 cans of cola. So now we do the same for lemonade. Right? The number associated with lemonade is 3, so we've got 3, and again, all of those numbers added together would obviously be 10, as usual, times 240. 240 divided by 10 is 24, times by 3, so we get 24, we get 48, and we get 72. Okay, again, you can use the bus stop method to verify. Now, you have two options here. With orange, you can do either working out the same way we've done, or you can just take these two numbers, add them together and subtract them from this, because keep in mind there's only orange, cola and lemonade. If we already know how many cola and lemonade there are, then I must know how many orange there is. So for example, if I have 10 cans of fizzy drink in total, 5 of them are Coke, 3 are lemonade, the rest are orange, then you can work out how many orange I have, right? Now, here it says half of the cans of lemonade are removed. So what's half of 72? It's 36. So I'm going to take away 36 from here, which leaves me with 36 cans of lemonade. Okay? Now, orange. The number associated with orange is the 2, so we're going to do 2 over 10 times 240. 240 divided by 10 is 24, times by 2 is equal to 48. And it says that a 12th of the cans of orange are removed. So what is a 12th of 48? Well, all we need to do is do 48 divided by 12, and if you know your 12 times tables, that's actually just 4. Times by 1 is 4. So we have to subtract 4 from 48, which is just 44. So now we know how many cans of drink we have. This has already given us 3 marks. Okay, so to show you where we get the marks from, you get a mark for doing these multiplications here, these fractions. So maybe I should put it under the fractions. Each of these is 1 mark in total, okay? You then get a mark for working out a correct number for each of these. So working out 120, 72 and 48 gives you a mark in total, so that's 2 marks. The third mark is for working out how many cans you have left after you subtract. So the first mark is for having all 3 of these lines written. Then you get the second mark for writing all 3 of these numbers, 120, 72 and 48. The third mark is for working out how many you've got left. The fourth and fifth mark are both for working out percentages. So how do I work out a percentage of a number? Right? Well, it says work out the number of cola cans as a percentage of the total number of cans remaining on the shelf. So how many cans of cola do we have? We have 120. So I'm going to do 120. And how many cans do we have remaining? Well, we have 120 plus 36 plus 44, which is equal to 120 over, well, 36 plus 44 is 80, plus 120 is 200. That is the fourth mark, and the last mark is for turning this into a percentage. So there's a bunch of different ways to do this, but in this particular case, to work out a percentage from a fraction, you can turn the denominator into 100, because percentage is always out of 100. So if I divide the top and bottom by 2, I get 60 over 100, which means it's 60%. Now the other way would be to just work out what this is as a decimal and times it by 100, or something along those lines. This, I think, is the fastest way, and that is your full 5 marks. Again, they like to try and confuse you by adding a bunch of information, but if you take it step by step, you can, even if you don't get the answer, you get method marks for working out stuff which isn't too bad. Okay? Work out 0.0004 times 0.32. So, whenever you multiply decimals, here's what we do. we remove the decimal point. So I have to move it to the right 1, 2, 3 times here and 1, 2 times here. So in total, I've moved it to the right 5 times. Okay? And that gives me 4 times 32. Once we work that out, we need to move it back to the left 5 times. Okay? So 4 times 32, if you want, we can use the column method. 2 times 4 is 8. 4 times 3 is 12, so 128. Now, at the moment, my decimal point is at the end, right? So I need to move it 5 places to the left. But I only have 3 digits. So I'm going to add a couple more zeros just to make sure I get the right answer. And again, because I moved this 5 to the right, I need to move this 5 to the left, okay? So, 1, 2, 3, 4, 5. My decimal point is now here. So my actual answer is 0.00128. Be really careful because this paper, or well, this question anyway, or a similar one, I can't remember, came up in one of my foundation maths classes test paper, the mock test they did in just before Easter. And they actually did the method correct, but they moved the decimal point the wrong number of times. They didn't move it 5 times, they moved it either 4 or they moved it 6. But the point is they got it wrong, okay? You lose half the marks if you do that, right? You get 1 mark for doing this, right? 4 times 32, so this part here. And you get another mark for actually putting the decimal point in the right place. So be super duper careful. For question number 8, we have Jenny drives from London to Swindon at an average speed of 54 miles an hour. She drives for 1.5 hours. Work out the distance from London to Swindon. So again, it takes her 1.5 hours to go from London to Swindon at an average speed of 54 miles an hour. Therefore, we need to work out the distance she travelled. Now, 1.5 hours is equal to 1.5 hours, right? Because a half is 0.5. So again, let's consult our trusty formula triangle here. Speed is equal to distance over time. We want distance. So we're going to do speed times time. So we're going to do 54 miles an hour times 1.5. Now there's a bunch of ways to do this. The way I like is when I have 1.5 hours, in 1 hour I've travelled 54 miles, right? In half an hour I've travelled half that. So I add on another 27, which is equal to 81 miles. Oops. Alexi is using a map. The scale is 1 to 25,000. On the map, a road has a length of 6 centimetres. Work out the length in kilometres of the real road. So, because of this scale, 1 centimetre on the map is actually 25,000 centimetres in real life. So we're going to do 6 times 25,000. Now, a trick that I like to use is any of the zeros at the end of a number, I actually remove them. And I'm going to do 25 times 6, and then all I'm going to do is add the 3 zeros afterwards. Okay? 6 times 5 is 30. 6 times 2 is 18, and plus the 3 would give me 21. So if I'm doing 25,000 times 6, I'm just going to add on the 3 extra zeros. Okay? And that's completely legitimate, but it makes the number a lot easier. Now that's in centimetres. Now it asks me to work it out in kilometres. So I need to go from centimetres to kilometres. So what I'm going to do first is I'm going to go to metres. And how do I go from centimetres to metres? Well, how many centimetres are in a metre? There's 100. So we're going to divide by 100. That just involves knocking off 2 zeros. So we have 2,100 metres. And then to go to kilometres, we divide by a further 1,000. Now, 2,100 metres means it must be 2.1 kilometres, right? And that in total is 5 marks. Not too bad, I think. I keep saying that, but if you're finding it tricky, then don't worry too much. For question 9, it's a bunch of standard form. My favourite, not really. Write 1.63 times 10 to the minus 3 is an ordinary number. So when you have the times 10 to the minus 3, you're moving the decimal point to the left 3 times. Okay? So the way I like to do this is I like to write a bunch of zeros in front of the number. right, just to help me visualize this. And then move it 1, 2, 3 times to the left. Remember, with standard form, when it's minus number here, you're moving the decimal point to the left. When it's a positive number, you're moving it to the right. So this here is going to be 0 point, because again, I don't need these two zeros, 00163. And again, just be super careful about putting the decimal point in the right place and putting the correct number of zeros. Then we need to write 438,000 in standard form. Now with practice, this becomes a lot quicker, as with the first part, okay? Because I know that when I have hundreds of thousands, I know it's going to be times 10 to the power of 5. That's because I'm old and I've done standard form like 1 billion times by now. But here's how you do it. You find the first non-zero number, which is 4. So we're going to put 4 there. Then you're going to put a decimal point. So again, you find the first non-zero number and you put a decimal point. Then you write every other non-zero number. So 3, 8, nothing else. Because you don't write the zeros. Okay? Now keep in mind, if this was like 4308, I would do 4.308. So you go until there are no more numbers, okay? There has to only be zeros. Okay? So in this case here, can you see I have a 0, but I don't stop there. I go until the end of the 8. So you go until there is no more numbers that aren't 0, okay? Now, all you do is you do times 10, and you work out, if I were to put the decimal point here, how many times to the right would I have to move it? Well, 1, 2, 3, 4, 5, and that becomes your power. Cool. Now you have to multiply two standard form numbers. So this seems quite tricky. However, there is a pretty neat trick with standard form. When you multiply two standard form numbers, or divide, or anything else, well actually no, just multiply, divide, you can multiply the first numbers first. So 4 times 6 is 24. And then all you do is you multiply the 10s together. Now when I have 10 to the power of 3 times 10 to the minus 5, if you remember your rules of indices, that means you add the powers. So this is 10 to the power of 3 minus 5, which is minus 2. Remember, I've added the powers. 3 plus minus 5 means you just do 3 minus 5. So that's 24 times 10 to the minus 2. That's 1 mark, not 2. Because with standard form, you cannot have a number bigger than 10 in front. 10 or bigger in front. So I have to have a decimal point here. So to do that, I need to divide the first number by 10, right? To move the decimal point here. Which means I need to times the last number by 10. So that becomes 2.4 times 10 to the minus 1. So if you'd like, all you're doing is adding 1 to the power here. Cool. At the end of October, Fiona's electricity meter reads 88,738 kilowatt hours. At the end of November, her electricity meter reads 89,198. Each kilowatt hour of electricity uses 16p. Work out how much Fiona had to pay for the electricity bill she used in November. Okay, so it's kind of interesting that you don't really need this bit here. Interesting. Well, you don't need it in the sense that you're not going to multiply this. So this might look like, and the common mistake is you just take this number here and you times it by 16. But you might be correct in saying that that is a very cruel thing to ask, right? Now, I don't know how many of you know how electricity meters work, especially considering a lot of electricity meters now are like smart meters. But the difference in these two numbers is how much she used in November. So the first thing we need to do is subtract them. Again, if you look how carefully I'm doing this, 8 minus 8 is 0, 9 minus 3 is 6. 1 minus 7 you can't do, so I'm going to go to my 9, cross it out, make it an 8, put a 1 there. Do it slowly, by the way. 11 minus 7 is 4. If you're doing it faster than me, bear in mind you're doing it faster than a teacher. Like, you should take your time. 8 minus 8 is 0, 8 minus 8 is 0. So she actually only used 460 kilowatt hours in November, which is what the question is trying to get you to do. So it isn't actually as unreasonable as you think. You're just doing 460 multiplied by 16. So you start with the 6. 6 times 0 is 0. 6 times 6 is 36. 6 times 4 is 24. Add the 3 is 27. Add the 0 here. 1 times 0 is 0. 1 times 6 is 6. 1 times 4 is 4. So add them together now. 0, 6, and 13. Don't know why that took me so long. And 7. So it costs 7,360p. So in other words, £73.60. But it doesn't say to give you a specific unit, so you don't have to give it in pounds. You can give it in pennies too. Part 11. Find the coordinates of the midpoint of PQ. Okay. There are a few ways to do this. You can kind of eyeball it, kind of look at it like that. Or you can be a bit more, I don't want to say sensible about it. I would rather say, a bit more mathematical about it, okay? So, the midpoint is going to be midway between P and Q. Shocking, right? So if I look at the horizontal bit, right? The difference in the horizontal, so how many squares are there horizontally between P and Q? Well, there's 1, 2, 3, 4, 5, right? There are 5 squares between P and Q horizontally. So the midpoint will be half of that. Halfway between them, yeah? So that's 2.5 squares. So all I'm going to do is I'm going to take minus 3 and add 2.5. So minus 3 plus 2.5 would give me minus 0.5. Which is right here. That's 1 mark done. Vertically, I'm going to do the same thing. There's 1, 2, 3, 4, 5, 6 squares vertically difference between them. So half of that is 3. So that would just be minus 2 plus 3 is 1. Okay. There is actually another way to do this, and I'm going to show you it now. So again, I'm going to go back to the 1, 2, 3, 4, 5, right? So midway between it would be here, and midway between this is here. So all I'm going to do is look for where those two parts cross. That's right here, which is at minus 0.5 and 1. So that's another way you can do it. Both ways are completely acceptable, of course. But I wanted to give you multiple methods just so you can pick one that kind of suits you. I'll put the link to this paper, by the way, in the description so you can find it. Along with the mark scheme too, just in case you want to look at it. Okay. Here are 2 triangles on the grid. Write down the scale factor of the enlargement. So the way I like to do this is look at the flat side. So it could either be a vertical side or a flat or a horizontal one. But you want to look for a side that's kind of along the grids, if that makes sense, like along the straight lines. So this top part here is 3, and this part here is 6. So what do I times 3 by to get to 6? I times it by 2. So the factor of enlargement is 2. On the grid, mark with a cross X the centre of the enlargement. So how do you find the centre of enlargement? Well, here I'm going to have to do something a bit spicy. I need to use a ruler. What you do is, can you see, actually before we get going, that this point here corresponds to this point here on the other triangle. And I'll pick another colour. This point here corresponds to this point here. And lastly, this point here corresponds to this point here. What you're going to do is you're going to draw a straight line through the points of the same colour. Okay, and that will give you a centre of enlargement. Well, I'll show you how it gives you the centre of enlargement. So please bear in mind that, again, it might be between these two things, which is kind of annoying. So a nice straight line. That's going to be quite easy. It's just a flat line. And where they all cross, where they all intersect, That is your center of enlargement. Okay. Yeah. Using a ruler on a computer is real fun, isn't it? Okay. It's not bad. It's terrible. But this point here is the center of enlargement. Easy peasy. Just where they all cross. Here are two parallelograms on a coordinate grid. Parallelogram D is a reflection of C. On the grid, draw the mirror line and then write down the equation of the mirror line. Interesting. Okay. So this requires a bit of eyeballing. A little bit of eyeballing. But with this, can you see it kind of, if you looked at it diagonally, it's just gone like that, right? I know that it's not vertically changed, right? So it hasn't been, the mirror line isn't down the middle because it's not directly opposite. And it's not like this either because it hasn't been flipped over. So the only other possibility it can be for you guys, right? So again, remember it's either vertical, horizontal, or it's a direct diagonal line, okay? So this should be an angle of 45 degrees. Look at that. Perfect. That should be what it is. So again, for foundation, there's only three possibilities. Either it's flipped vertically, horizontally, or it's diagonal, right? And the equation of that line is a straight line through the origin, so it's always going to be y equals to x. Okay, then we need to work out this as a mixed number. There's a ton of different ways to do this. You can add. So first of all, the method that I would probably suggest that you do is turn them into improper fractions, then add them. But with adding and subtracting, you can just add the whole numbers and then add the fractions separately. Okay? Either one of them's fine. I'm going to do it the longer way because I think it's the proper way. But for those of you that are a bit clued on, you're quite good with fractions, kind of handy. You can just add these mixed, the whole numbers here, so 1 plus 2, and then work out what 3/5 plus a quarter is. But I'm going to change these into improper fractions. So to turn this into an improper fraction, you do 1 times 5, which is 5. Add the 3 is 8, so it's 8 over 5. 2 times 4 is 8, plus the 1 is 9. So 9 over 4. Now to add two fractions together, you must make their denominators the same. So I'm going to times the first one by 4, top and bottom. I'm going to times the other one by 5, top and bottom. 8 times 4 is 32 over 20. 9 times 5 is 45. 20. 32 plus 45 is 77 over 20. Now, in order to turn this into a mixed number, I ask myself, how many times does 20 go into 77? Well, 20, 40, 60, then it would be 80, so I can't do that. So it goes in 3 whole times. And what's the remainder? Well, I'm at 60, I need to get to 77. So 77 minus 60 is 17. So, and 17 over 20. Then you would simplify, but we can't in this case because 17 is a prime number. Show that 2 2/3 divided by 6 is equal to 4 over 9. So again, we need to turn this into a improper fraction. So 2 times 3 is 6, plus the 2 is 8. So we have 8 over 3 divided by 6. Now, when you divide two fractions, you may know KFC. You keep the first fraction the same, you flip the second fraction, and you change the sign. But if you notice, 6 isn't a fraction. But you can make anything a fraction by just putting it over 1. So I keep the first fraction the same, 8 over 3. Flip the second fraction, so it's 1 over 6. And I change divide to a times. So 8 times 1 is 8. 3 times 6 is 18. And then, that's not the answer though, right? That doesn't look like this. But we need to simplify. So divide top and bottom by 2. And we get 4 over 9. Cool. For some of these, you also just need to know certain values of trig. This is a grade 5 topic. Okay, so in my opinion, and I don't want you to get super mad at me if this does come up, This hasn't turned up in any foundation paper so far, and it's unlikely to. But if you're actually aiming for a grade 5, the absolute peak of foundation paper maths, this might be useful. I'm going to show you, basically it's a half. Now I'm going to show you an easy way to remember this. This was actually in my, everything you need to know in Edexcel or AQA Maths. Both of those videos have it in because it's in both topics. Here's what you do. For the values of sine that you need to know 0, 30, 45, 60, and 90, okay? And this is for sine. All you're going to do is go up in ones. So, but you're going to square root of 0 over 2, then I'm going to increase it by 1 each time. That's it. Can you see all I'm doing is counting? 0, 1, 2, 3, 4. But Mitchell, I hear you ask, square root 1 over 2 isn't half. Well, if you work it out, what is square root of 0? 0 over 2 is just 0. Square root of 1 is just 1, so it's 1 over 2. Square root 2 over 2 is just square root 2 over 2. As is square root 3 over 2. Square root of 4 is 2. 2 divided by 2 is 1. So these are the values you need to remember. But the trick that I use is this. All you do is you count. 0, 1, 2, 3, 4. That's it. Nice and easy. And that's how I remember them. Now, I will also say that with practice, if you ever practice this, you will just remember them. Same with your times tables, right? The more you do them, the more you remember them. Okay. The centimetre grid shows the plan and the front elevation of a cylinder. Work at the volume of a cylinder. Give your answer in terms of pi, because obviously we don't have calculators. So if I were to draw this shape out, because again, with these plans, you should be able to draw the shape. We have a circle, and the cylinder's like this, right? Now the volume of a cylinder is the area of this circle times the length of the cylinder. So it's pi r squared, which is the area of a circle, times length. So now, using this diagram, we should work out what each of these is. Okay. Now, the length is just this length here. 1, 2, 3, 4, 5. So I know that this is going to be a 5. The radius, well, that's the distance from the center of a circle to the edge. So we're going to start from here, and we're going to go to here. Well, that's 1, 2, 3. So the radius is 3. So we're going to do pi times 3 squared times 5. 3 squared is 9, so we've got pi times 9 times 5. 9 times 5 is 45, so the answer is 45 pi, and we should probably leave it as centimetres cubed, as I suspected. Pretty tricky paper so far, not going to lie, and we're over halfway there, so if you're getting a bit tired, just know that I'm feeling twice as tired. No, I'm kidding. I'm feeling pretty tired too. Let's just get through this, and that will be our revision for the day. So here's a quadrilateral ABCD. All the measurements are in centimetres. The perimeter is 52 centimetres. Work out the length. And if you notice, 4 marks. Okay? Again, this is a question where you need to use the information one by one. Just slowly work your way through, okay? 4 marks means you can spend around 4 minutes doing it, okay? Which is quite a long time. Now, the first thing I can imagine is that you're probably crying to yourself because this is all in algebra. But don't panic. A lot of students will look at this, crap themselves, and then skip the question or panic. Your mindset is everything whenever you do anything, even in exams and everything else, okay? Keep calm, and I promise you it's not that bad. So, it tells me the perimeter is 52 centimetres. And what is the perimeter? The perimeter is all of these lengths added together. So what if I just added all of these sides together? Right? Okay. So x plus 1. So I've done this one. Plus x minus 1. X minus 1. So I've done this one. I like to tick them off because I do have a tendency to miss things out. Plus 2x minus 5. There you go. Now, that equals 52, right? Because that's what it tells me here. This is 1 mark done already. Have I done any maths? No. All I've done is written out what the question has said. I've got a mark, which is one more than a lot of students will get. Now what I want to do is simplify just this left-hand side. So if I look at this and ask you to simplify it, could you do it? Well, I look at the x's first. So I have 1x, 2x, 4x, 6x. I have plus 1, minus 1 is 0, minus 5 is minus 5. And this is literally how I'll do it, you know? Then I'm going to add 5 to... Now I'm just solving this equation just like we did right at the beginning of the paper, right? What's stopping the x from being by itself? Well, this 6 and this minus 5. Get rid of the thing that isn't attached first. So don't get rid of the 6 first. So add 5 to both sides. Gives me 6x. Minus 5 plus 5 is 0, so I don't need to write it. Equals 57. Now I'm going to divide both sides by 6 because this 6 is timesing the x. So x is equal to... Now 56 doesn't go into 57, so let's use the good old-fashioned... Well, I mean, we can't really use the bus stop method, really. But, I mean, we can, but it's not too useful. 6 doesn't go into 5. How many times does 6 go into 57? Well, it goes in 9 times, right? And what's left over? 3, okay? Because 9 times 6, 9, 80, 27 is 54. It's 3 remainder. So add a decimal point, and don't forget to add the decimal point on top as well. That's another mistake. We add the decimal point 0 here, but then we don't add it up here, which means we get a really weird answer. Remainder 3, so then we get 5. So some students will get 95 because they forget to put the decimal. Or more likely, they'll look at that and say, but it can't be 95. I've done something wrong. Skip the question. No. Bad. Okay? By the way, you get another mark for getting 6x minus 5. And then for working out that x is equal to 9.5 centimeters. So that's 3 out of 4. It says to work out the length of DC, which is just 2x. So all you need to do for the the fourth mark, is do 2 times 9.5. 2 times 9 is 18. 2 times 0.5 is 1. 18 plus 1 is 19. Muy bien. Okay, don't know about you guys, but my throat is getting a bit dry, so I'm going to take a second to drink some water. I'll probably cut this out. Hope so. I do hope I cut that out, because otherwise, yikes. Here is a regular hexagon and a regular pentagon. Work out the size of the angle marked x. Now this is pretty interesting. There's a couple of things we can do. Quite a few things we can do, actually. There's a few equations that we can do in order to work this out. And I think the easiest way to think of this, and bear in mind in the mark scheme, there's going to be 2 methods as well, because again there's 2 ways of doing this. If I work out what this angle is here and this angle is here, I'll be able to do 360 minus these 2 angles to work out x. So this here is the hexagon. Now regular means all of the angles are identical. But what are the angles in a hexagon? Here's an equation I would recommend you remember. This is for the total angle in a shape. An n-sided shape, okay? How many sides does a hexagon have? 6. So we're going to do 6 minus 4. Sorry, 6 minus 2. Goodness gracious. Which is 4 times 180. So double it is 360, double it again is 720 degrees. Now that isn't the angle here, because each of them, don't forget, what am I trying to say? Each angle is the same, so we need to divide it by how many angles we have. In a hexagon there are 6 angles, so we divide by 6. Now if this looks a bit scary, I'm going to show you another division trick. If your number ends in zeros, remove the 0 for a second. What's 72 divided by 6? It's 12. And then we're going to add the 0 back onto the end of the answer. So the answer is 120 degrees. So that's what this one is. We're going to do the same thing for the pentagon. There are 5 sides to a pentagon, minus 2 times 180. So that's 3 times 180. 3 times 18 is 54, so that's 540 degrees. and we need to divide by 5. I can show you how to divide by 5 really quickly. Divide by 10 gives me 54, and double it, 108. That's 108 degrees. So then x, all we're going to do is add those two together, which gives me 228 degrees. And that means x is just equal to 360 minus that. Okay. That makes 5. So that makes 2, 3, 1. 132 degrees. Again, there are alternate methods of doing that, but this I truly wholeheartedly believe is the best way of doing it, okay? Cool. Complete the table of values for y equals x squared minus 3x plus 1. Great, I'm so excited. This is going to take a while. Okay, so what they mean by this is we're going to take these x values and sub them into this equation. So if I do the minus 1 first, instead of x, we're going to write minus 1. So y is equal to minus 1 squared. Don't forget to put it in brackets. A lot of students don't do this, and then I laugh at them when they make a mistake. No, I'm just kidding. That would be 1 plus 3 plus 1, which is 5. Now we're going to do the same thing for 2, and so on. There's no pattern to this, by the way, so you just got to brute force it. So that's 2 squared is 4. Oh no, I'll do it again. Minus 6 plus 1. So that is minus 1. Do the same thing for 3. And I'll go through what the mark scheme is in a second. So 3 squared, that would be 9 minus 9 plus 1 equals 1. Same thing for 4. 4 squared minus 3 times 4 plus 1. That's 16 minus 12 plus 1, which is 5. So in terms of the mark scheme for this, you lose a mark for every value you get incorrect. So if you get 2 incorrect, you get 0, which is a bit harsh, but is the way it is. Now each of these makes a pair of values, right? So minus 1 and 5, we're going to look at minus 1, then we're going to put a cross on 5. 0 and 1, right? So we're going to find 0, find 1. There. 1 and minus 1. 2 minus 1, 2 minus 1's here. 3, 1. 4, 5. Now, I want to be perfectly clear here. Do not connect the dots. If you connect the dots like this, and then straight across, you're going to get nothing. There shouldn't be a flat bottom. This is an x squared graph, it's a curve. So you don't have to be like Michelangelo or anything, and you guys know that I'm definitely not. I will say I'm much better at this in real life. You want to draw a smooth curve that goes through all of these points. And your pen shouldn't leave the paper, even though mine just totally did. Yeah, that's horrific. But again, on paper I'm a lot better. You just drew a smooth curve. Yeah, like a U shape. Nice and smooth. Since I'm a bit cramped, I'm like, yeah, I'm making excuses basically. And, oh dear, it says using your graph. Okay, so that means I have to do this more smoothly. Perfect. I'm so excited. Okay. You're going to see a level of concentration you may not have witnessed from anyone before. So let's be really careful with this. Yeah. Oh, God, I hate this. It's better, right? It's not great. Again, on paper, you'd be able to get a much more accurate answer. So it says, using your graph, find estimates to the solutions here. So this solution is just where this graph equals 0, which is here and here. Your values, if you printed this out or you just did it better than me, which is probably quite possible, are going to be more accurate. But here it's going to be 0.4, which is actually one of the answers. And 2 so that's 5, 2.6, 2.7. 6 or 7. Let's do 6. Perfect, right? Because that is just with the x values where it crosses, right? So I'm just reading off the x values here. A car factory is going to make 4 different car models, A, B, C, and D. 80 people are asked which of the 4 models they would be most likely to buy. The table shows information. Cool. The factory is going to make 40,000 cars. Work out how many Model B cars they should do. So I'm going to put a little star next to that. So the way this works is you use this information in the table to work out how many they should make. So the way we do that is we work out what fraction of people liked Model B. So I take the 15 and I divide it by the number of people we have, which is 80. I'm going to simplify this by dividing top and bottom by 5 because I believe it will make my life easier. It's 3 over 16, which isn't much easier. Oh dear. Okay, that's fine. You know what? Bold move. I'm going to leave as 15 over 80. Okay? And we times that by 40,000. So if you remember, to take fractions of an amount, we do 40,000 divided by 80. So the first thing we can do here is actually cross off a 0. So that's 4,000 divided by 8. So 4,000 divided by 8, you can half both of those to make it 4,000 divided by 8, half the top and bottom number. So 2,000 over 4, 1,000 over 2, and that makes 500 over 1. So that's 500, and then you times that by 15. So you're doing 15 times 500. So what we can do here is save these zeros for later. What's 15 times 5? Well, 5 times 5 is 25. 5 times 1 is 5, plus 7 is 7. Then add on the 2 zeros. So they should make 7,500 Model B cars. Yeah, it's definitely getting a bit more tricky, isn't it? Just so you know, 24 is the last question. We're on question 20 now, so last stretch. But this is where things get more spicy. Rizwan writes down 3 numbers, A, B, and C. A to B is 1 to 3. B to C is 6 to 5. Find A, B, C. Okay, that's not too bad. To combine ratios, you need to find the letter that's common, which in this case is B and B. And you have to make the number associated with them the same. So in this case, B is 3, and in this case, B is 6. So I'm going to times this first ratio by 2, which gives me 2 to 6. And this is still 6 to 5. And then all you can... Now, since the number is the same, we can actually just combine it. So A to B to C, A is 2, right, from here. B is 6 from here and here. And 5 is the other number here. Express A as a fraction of the total of the 3 numbers. We did this before, right, with the Kohler question. The number associated with A is 2, so we're going to do 2. Over all 3 of these numbers added together. 2 plus 6 is 8, plus 5 is 13. And that is 2 marks. Emma writes down 3 numbers, M, N, and P. Find M to P. Okay, so, a few ways to do this. We just want M to P, right? So I'm going to take this value of N and sub it in to this equation. Okay? So that's P is equal to 5 times 2M. So that's P is equal to 10M. So what this is saying is P is 10 times bigger than M. Okay? So in other words, that is for M to P, you have 10 to 1 ratio. Because P is equal to 10M, it's 10 times bigger. So, sorry, I actually wrote this the wrong way around. It's 1 to 10. Because P is 10 times bigger than M, right? So P should have the 10 in front of it. That was quick. Another inequality question. So again, take it step by step. It looks uglier, believe me, I agree. The 5, the 2, and the 3 are all stopping the x from being by itself. So you start with the one that isn't attached. So I'm going to minus 3 from both sides. That gives me 5x over 2. And then plus 3 minus 3 is 0. It's greater than 15. With this next step, I can get rid of the 5 or the 2. Dealer's choice. You can choose whichever one you want. The 5 is timesing the x, and the 2 is dividing the x. So if I were to get rid of the 5, I would need to divide both sides by 5. So that gives me x over 2 greater than 3. If I wanted to get rid of the 2, I'd have to times both sides by 2, which is what I have to do right now. So x is greater than 6. Okay, factorizing. I actually quite enjoy this. You think of two numbers that times to give me 9 and add to give me 10. Okay, so if I write down the factors of 9, I have, 3 and 3. Can those add to give me 10? Nope. What about 9 and 1? Can those add to give me 10? Yeah. So 9 and 1 are my numbers, so you put 9 in one bracket, 1 in the other. Either way round is fine. So x plus 1, x plus 9 is also completely acceptable. Simplify this, given your answer as a power of 2. Oh boy, this is actually pretty spicy. What we're going to do here is a few things that we could do. Oh, there's a mistake on this paper. Interesting. So that's actually really interesting. I need to report that. I need to report that to Edexcel. That's very funny. It should be 2 to the power of 8, not 28. So when you have two things multiplying, you add the powers, which gives me 2 cubed squared. Now when you have a power to the power, you multiply the powers, which is 2 to the power of 6, which is the answer in the mark scheme. So that's very interesting that they've managed to get that wrong. I've never seen this paper before, by the way, although some of these questions were in the mock that my school happened to do. It's just that I opened up the mark scheme when I saw that, and that's why you heard me stumble for a second. So if you download this paper at home, just be aware, it's not 28, it should be 2 to the power of 8. Okay? I didn't change that myself. The question itself is wrong. Interesting. So here are two cubes A and B. A has a mass of 81 grams, B has a mass of 128. Work out the density of A to the density of B. Okay, so density is just mass over volume. So let's work out the mass and the volume of each. Well, the volume of each of these. We don't need the mass, right? So the volume of A, the volume of a cube is just 3 times 3 times 3 times all the lengths together. So 3 times 3 times 3. 3 times 3 is 9, times 3 is 27 centimeters cubed. For B, the volume is 4 times 4 times 4. If you've played enough Minecraft, you should know how much this is. 4 times 4 is 16, times 4 again is 64. Okay, so my density for each of these, density for A is going to be 81 over 27. Now, because I'm an uber nerd and I've done this so many times, 81 divides by 27 3 times. So yeah, 27, 54, and then 81. I hate myself for knowing that, believe me. And for B, we have 128 over 64, which again divides perfectly into 2. So the ratio of A to the density of A to B is just 3 to 2. 3 marks. So in terms of the marks, where you get that from, you get a mark for working out the volumes, a mark for the densities, a mark for the ratios. Quite standard, really. And we have one last question. So how long did that take us to do? I have cut out some bits of this, so just for me personally, this has taken us 58 minutes. But again, might have done something different. Okay, the diagram shows 3 identical rectangles, A, B, and C. And this looks interesting. 5/8 is shaded, 9/11 C is shaded. Okay, interesting. So, this is 5/8, this is 9/11. So all we're going to do is work out how much isn't shaded for both of these, right? So for A, the amount that is unshaded is just 1 minus 5 over 8, which of course is 3 over 8, right? Because if this much is shaded, then, so 5/8 is shaded, then 3/8 must not be. With C, we're going to do the same thing. Is 1 minus 9 over 11, which is 2 over 11. So, To work out how much of B that is shaded, we're going to take the whole, 1, and subtract the 2 unshaded parts here. So I need to first work out what 3/8 plus 2/11 is. So to do that, I need to make them the same number, and that means I need to times them by each other. So 33 over 88 plus 16 over 88, which is 49 over 88. Cool. 1 minus that, so this is the unshaded parts. So the shaded bit is 1 minus that. So how much do I add to 49 to get 88? I add 39. Which is the final answer. So yeah, I hope you enjoyed that. Share it around if you'd like, and if you find it useful, please let me know in the comments, because then I can do a paper 2 and a paper 3, depending on how well this video does and all of that fun stuff. But hopefully it helps. If there's any questions at all, please let me know. My email is also in the description in case you would like to email me any questions that you may have. But other than that, I hope you have a wonderful day and best of luck with your revision.